Guess who's back in Matrickz Tech Talk today? The legendary functional safety expert Hans Leo Ross is back again. Leo, welcome to Matrickz Tech Talk.
Thank you very much, Hassan.
Yeah, so we had Leo in one of our previous episodes in 2018, end of 2018, I guess. It was a very popular episode. We had a lot of engagement with that episode. So thank you so much for being highly engaging. So we have Leo once again, and you have all the chances to ask questions in the comment sections. So I'm really looking forward to that, looking forward to your engagement. Now, without further ado, those who didn't watch our previous episode with Leo, can you tell a little bit about yourself, your passion and your background?
It's now nearly 30 years ago when I started at the end in the oil and gas industry with automation. And at that time, I think safety was not that well recognized. We had quite a lot of topics in safety, and I was the youngest in my engineering company, and the youngest had to do what everybody don't want to do. And so it came up that I have to make an automation for a liquid gas transportation system. And then a lot of questions related to safety came up. So we had to deal with the fire brigade, we have to deal with emergency systems, we had to deal at the end with automation, autonomous stopping functions, and it was at the end a rail system. So it was not a road system, it was a rail system. And a lot of safety requirements were given by the operator of the plant. Yeah. And then they try to find somebody who has passionate enough to do it. And as the youngest, you cannot say no. And so it came up to me that I have to deal with all that stuff. And so, I became at the end somehow also at that time a safety specialist in the oil and gas industry. And so I started my first automation project. It was a rail loading, so it were liquid gas wagons which are loaded automatically, and there was also automated driven locomotive in front of that, which runs at the end automatically and moves the wagons at the end according to the requirements of the loading station. And the entire automation system, we have to build up and also to bring it through the authorities and get the certification for that one, for the operation of such a system, because there are also quite a lot of humans around, that humans were working at the end. So all the workers had to be protected, and also people in that environment, etc. They had to be introduced in the explosion-proof systems, etc., and all that stuff. Yeah, so it was the whole program at that time. And I had to dig in all that stuff. And so I came into the safety business. Many years later, I started at the end as a salesman. And as a salesman, I have to sell safety PLCs. My sales area was Norway, Great Britain, and also East Europe. In East Europe, we make quite a lot of pipeline projects. And in the pipeline projects, we had quite interesting approaches, because you cannot control the pipeline from point to point. You cannot, at the end, just install radio communication. So we start, for example, with Europipe 2 in the North Sea, really a satellite-based pipeline monitoring system and a pipeline shutdown system for that one. And since we had that on satellites, we use redundant satellites at that time. We make backup lines with the telephone system, etc., and all that stuff. And later on, we recognize at the end that's a good quite technology, and it makes sense to monitor that really via satellite system and other system. So we start a program at the end in the North Sea, and they want to build up unmanned offshore platforms. And this unmanned offshore platforms requires at the end a lot of safety features, a lot of control. They need shutdown degradation systems at the end for those plants. And so that was also quite a huge program which we developed, and we're using also here satellites to monitor all these things. And in the second step, we use even shuttle tankers, which are moving at the end to the offshore platforms to bring at the end oil and gas to the onshore facilities in order to be more efficient, because at the end the pipelines are at the end not possible in that early stage of that platform. And so I think we use quite a lot of remote control with very interesting robotic features, I would call, to control at the end unmanned shuttle tankers to go onto oil rigs and to bring at the end oil and gas to the onshore facilities. That time was very interesting and very ambitious. I was deeply involved in the authorities to, at the end, get the certification for the operation of all that stuff. And then I started at the end to develop a really safety system. So I came always back to my company and I told, we need more remote control. We need more communication features, safe communication features. But at the end, the normal communication features like Modbus and CAN bus, whatever we're all using, was not really up to date. And so we have to develop concepts for Ethernet communication. And so we came up at the end to develop our own brand. We called it at that time Safe Ethernet. And we start really a lot of automation programs at the end based on Ethernet, where we had at the end the control completely in a network and not anymore based on different safety PLCs. And so later on, I became at the end the head of the product management. And so I had to marketing all the products in different areas and to increase the development and to promote at the end the product features to sell that. Was very interesting time. And then about 2004, I get a call, and that call at the end was from a headhunter from the automotive industry. And he said, we need something like that in safety, also in the automotive industry. How can we work with you, and how do we find at the end the bridge to you? Then I started at the end in the automotive industry. I think my second working day was already in a Cremium from VDA, where we start founding the group who develop at the end ISO 26262. I don't know if I can show that to you in the camera and if you can see it.
Yes, the birth certificate.
Later on in the system, this is the birth certificate of ISO 26262. That was a public communication between the TÜV organization, so the VD TÜV, that is the umbrella organization of the TÜV. He stated, the new IEC 61508 is important at the end for safety also in automotive industry, but it is too wide and too general at the end. And we need at the end a specific standard for the automotive, which address at the end all the specific issues at the end in automotive industry.
So this is historical, Leo. You showed the birth certificate, literally the birth certificate of ISO 26262.
No, that was the birth certificate. It was a public letter which were at the end between different organizations. And they said the state of the art. And since they confirm in a written and a public note that it is state of the art to have at the end to fulfill such a standard, there was at the end necessary due to product liability to fulfill at the end such things. And at that day, the specialist said IEC 61508 is too general, so we need our own. And our own was at the end the development of ISO 262. So we started at the end the development of ISO 262 at that day. That was in the year 2004.
That is fascinating. I'm sure a lot of our audience are going to have a goosebump. I'm already having a goosebump that, really literally the birth of ISO 26262, the standard that we use so widely, was conceived that day, and you still have that letter. So it can't help showing what I have in my hand. Anyone who's looking for amazing literature, I think that's the only literature that really comprehensive about ISO 262 functional safety in automotive is Hans-Leo Ross's book. Leo wrote several books. I have several of them. One of them I have on my table. This is a German one. Leo, do you mind showing the other books that you have in the background for our audience? Sometimes I get this question. So what would be a book for functional safety? And I, without any question, I recommend your book. Do you mind showing the English one also maybe?
The first book was at the end written with the Hansa publisher, and Hansa at the end asked me to write a book about all the background information from ISO 262. So at that time, we were in parallel in a funding project called SAFE from IKEA. And here we collect at the end all the necessary engineering stories and the background information, etc., what we need, how we develop at the end a safe architecture, how we develop a safe software, etc. The ISO 262 only requires at the end the different activities which are necessary to do so, but how to do such things. So what is the methodology behind? At the end, I try to summarize here in that book. When I started with the book, we were 3 people writing the book. But unfortunately, I was the only person left who finished the book. And so I think I became a book author. Then I think a lot of people from international audience came to me and said, it's very nice, the German book, but we need at the end also an English version. And when I started working with the English version called Functional Safety for Road Vehicles, in the English version, I start already writing more about software safety. So I found out that I left quite a lot of topics about software safety that I need to add at the end here some points. And so the English book became at the end very different from the German book. So it was more deep to software technology, and I made also the first statements about security and safety, how to combine, etc. So all that stuff which was excluded from ISO 262. Also the today discussion about SOTIF and other domains. We had quite a lot of background information, but at the end, at that time, it was not scope of the standard to write about all that stuff in the standard. And so we specify just the requirements in ISO 262, which are necessary to develop an electronic system for functional safety in road vehicles, and not all the background information. And when we start working with ISO 262, I think it was quite ambition, because at the end, all the discipline, all the way how we make software, etc., we didn't want to make it as extreme as we want to do it in the avionics industry, but we recognize that we need the same mechanism and the same principles. But at that time, we still had at the end most of the systems in the vehicle which were under control of the driver. So brake system, steering system, the motor management, etc., was all in responsibility to the driver and not at the end somehow automated. So at the end, the degree of automation in a normal road vehicle at that time was very low, and we had nearly no automated functions. So we had just assistant system, and at that time also there are some minor assistant system, and ISO 262 also stated that the nominal performance is exempted from the standard. So we just consider this really as a basic support system for the driver, which never took over any task which the driver officially has according to the regulations. And so it came up at the end to write the first book about general safety in German language. So I start at the end here. I put at the end most of the topics from a legal point of view. And we had quite a lot of German. So we have in Germany one of the oldest road traffic regulations, which are more than 100 years old. And so I start the different perspective at the end of road traffic regulations here in Germany. And it is a very German book. So all the examples, all the principles that I were explaining and the legislation background, etc., was very German. And you can imagine when we start with ISO 262, there was already a legal requirement. It was the UN ECE 79. And in the R79, we had an Annex 6, which requires for all the overrides of steering and braking system a safety concept. And the legal regulations say, please have a safety concept. But according to what standard, what principle, how to do it, etc., was a big question mark. And so at the end, we concentrate in ISO 262 to give an answer how we can make such a safety concept. But now it became much wider, that we have to do much wider things in terms of safety. So at the end, there is safety in use, for example, so that a driver can manage all the functions within the vehicle. I think most of the ergonomic aspect we had in the vehicle, the steering wheel, the brake pedal, the gas pedal, the park brake lever, etc., the gear switch at the end, were all things which were in the nature and didn't change really for 100 years. So we had an automatic gear level, but we had some changes here. But the arrangement of the pedals was, I don't know exactly, but as far I know, we have it before the Second World War already in that arrangement, how we have it today in most of the vehicle. And just change from manual gear system to automated gear system. But that was the main automation approach that we had at the end till the change of the millennium. And in the change of millennium, we got really slightly this kind of automation ideas. And also electromobility was not that big story for the automation. And you know, today it is a sad story for the German auto industry that we really are not anymore in the leading position with electric vehicles. So Tesla is the brand which counts and which tells us where is the front end of technology in electromobility. And we don't have at the end here in Germany adequate vehicles. I think now slightly with the ID3, some new vehicles come up. Renault had done some, so we did at the end 10, 15 years ago, the first things, Better Place, tried to make an approach with battery exchange systems, etc. But they never come really into the market. Yeah, and today in the last 3 years, still till the diesel scandal, we realized that the combustion engines are not anymore state of the art. So the big requirement for the society and for the people is really having at the end green mobility, having at the end a clean car, which don't pollute the environment. And when you are at the end with friends discussing, I have an 8-cylinder with a perfect sound, etc., nobody cares. And he says, yes, as a historical car is very nice, but our today mode of transportation is a clean vehicle and, of course, also a safe vehicle. And so the industry completely changed, and especially now due to the Corona pandemic, we realized really that it getting very strong acceleration, much more accelerated than we had it previous time. And the problem is really now another aspect which is close to safety in use. This is the human capability. Can the human really build? So you maybe know the discussion from the electromobility charging a vehicle. At the moment, even the comfort and the usability, how to charge electric mobility, availability of charging stations, etc., and all that stuff is a big question mark. How do we get them, and how can we at the end make it in that way that it is comfortable for the people? And of course also fuel tanking costs you about 10 minutes. And now we are talking about nearly 10 hours of charging an electric vehicle to get a distance of about 500 kilometers. That is not at the end, that's what people expect. And so at the end, people quite start asking, what do we need? How do we need? And what do we pay for? So what is the value at the end that you need, which give you a good mode of transportation? And we have on one hand, of course, people, individual transportation. So at the moment, my benefit is when I want to use my car, I step into my car and drive wherever I want. And even the borders at the end in Europe became at the end open, so you can even drive to Switzerland, to Italy without any limitations. You pay today in most countries with euro here in Europe, and you have not even the problem with the currency and all that stuff. So you have a huge freedom, and now you start back with electromobility, and you have to see how can it work and how can it manage. Do I find charging stations somewhere on the motorway? I'm able to use it. Do I have the comfort? And so at the end, the value for individual mobility is strongly depending on usability. And if we get it really done in a safe mode. And that is at the end, the next question which came up, not only in a safe mode, also in a very reliable mode. And when we are talking about a reliable mode, we realized at the end there is a big mismatch. Nearly all the safety concepts that we have developed in the past years were at the end shutdown systems. So they all saw at the end the safe state when the system is de-energized. And de-energized means for a motor vehicle, it is somewhere standing, maybe on the road, maybe on the shoulders of the road, or in a parking lot when you are lucky. But if you are on the motorway and you don't have energy, it is not a safe state. So it's very dangerous when you have cars at the end in the main road. Maybe you need even energy at the end for the flashlights in the vehicle or the position indicator, the warning lamps, etc. And all that energy is necessary. And so you need at the end energy in the vehicle. And that makes us believing that we have a huge energy discussions. So in Germany also, that we can build just charging station. Do we have really the means of transportation of energy available? And so we recognize that even the power lines in Germany are not in that mode that we can really provide at the end for any household an adequate charging so that you get your wall box somewhere. Especially in Munich, for example, in the big cities, you cannot provide for any car a wall box in your house. Especially in rental house where you have quite a lot, you don't have at the end now the energy network to provide all that energy at the same time. Since most of the people coming home in the evening, about 6 o'clock in the evening, starting or charging the vehicle, you wouldn't get immediately a power failure because the complete network fails immediately. And that is our questions. So we have at the moment vehicles like the Tesla, for example, which are more than 2 tons of weight, 2 tons of weight, just to carry an 80 kilogram person from one point to the other point is not a good average. And how to make that efficient and how to bring that really in a mode that you can make here really a beneficial and also a clean way of transportation needs other ways.
So you have actually laid a lot of stimulating issues in your discussion. You kind of touched where are we going in terms of electrification? What is the future of mobility? That is the direction you got. Here I want to mention a viral video that was really viral in the social media. Probably you've seen that. So somebody is driving a Tesla and carrying a diesel generator in his trunk to charge that Tesla. So this kind of like resembles with the example you gave that we're used to the fact that it takes 5 to 10 minutes to fill up my gas, but it takes 10 hours to charge, right? So the workaround was, carrying a diesel generator to charge your Tesla when it runs out. So obviously that's a joke. What do you see the future? What to do? You mentioned Tesla being in the forefront of electromobility, not the German brands, although we had electric vehicles way before Tesla existed. So I want you to touch a little bit that what do you think of the future, where we're going? You laid out the problems that, it's not possible in all the cities and all those. What should we do? What would be the solution? How do you see the future of mobility?
The question is, when do we see the future? The question is really a matter of, do we consider after the Corona pandemic, or do we consider at the end 5 years horizon, or do we see 10 years of horizon? I think especially when we look at the end in the 5 years horizon, we need a kind of mix. I think at the moment situation is due to the pandemic, people are questioning, should I buy at the moment an actual vehicle? Should I buy a new vehicle? Since he knows in 5 years it is an old technology vehicle. So at the moment it seems so that with our diesel vehicle we cannot go anymore into the cities. I think most of the cities plan to ban the diesel engines and I think at the moment we know the battery capacity is not there where we want it. We get slight improvements with that one. At the moment when you see, it seems to be based on the technology. At the moment we have liquid lithium-ionic batteries, and maybe if we have other technology we come to half of the weight or double of the distance with the same weight of energy. And so we're coming up in an area of 800 kilometer per charge. Maybe we can reduce the charging speed so that we come down to load for 800 kilometer, maybe in 1 hour or maybe even less, or like inductive charging during driving in some areas, etc. We will find solutions for that one, which will improve that. But the question is really, do we really like to own such a car anymore? Because the use case that we have at the end are very different. And for example, now during pandemic, most of the vehicles are standing around. You don't need it, because also 2 years ago or 2.5 years ago, we met in person. Today we are talking virtual together, and we have to do it virtual due to the restriction of the coronavirus. And so we have to deal and have to think, do we need all that mobility? And also you see a problem with most of the airlines. They suffer very strong with the situation because most of the people try to find solutions in a virtual mode. But virtual mode is one point. You cannot virtualize everything. And so in the fourth book, I had such a slogan: everything which you can't digitalize will become very valuable in the digital age. The question came up for me, what is the value people need and how they want to have the situation? So I think you're living in Munich, and in Munich already you can at the end rent a car with your app and take it wherever you can. You require it, you park it wherever it's possible. You have all the information in the app available about your rental car, etc. And you use it for that purpose. When you need a car to go skiing, then you rent an adequate car with an all-wheel drive and stuff like that. And you have an adequate car which is tailored for your requirements, etc. And when you are coming back from skiing, you're going back to a smart type of car, which is more comfortable to moving in big cities with a lot of traffic. And of course, with some automation features, yeah. And this kind of automation feature, especially when you are in a traffic jam, you don't want to care about all that stuff. You remember last week when we were calling, you were in the car, etc., but you had always to concentrate on the traffic and you have to watch the traffic. You prefer to have a perfect compartment, and in that compartment you want to work, you want to call, maybe you have even a keyboard available where you can type in, you can write emails, letters, etc., and reading text during the time you are in the traffic jam. And you don't want a vehicle anymore just to feel driving, because at the end it is just a mode of transportation for you, and it is a tool for you, and it is not anymore enthusiastic part. And the question is really, when you don't want to own such a, or what is the reason to own such a car when you just have a restricted use? where you need transport mode, and what we pay, what the value for us is different. So a movable office would be for most of the business people the best solution, and not anymore really a vehicle which have a lot of horsepower, a lot of other value. So the old values are going away, and yeah, I think most of the preferred solution would be really a movable office. And such a movable office, I think, has a lot of advantages. And the other point is really, do we need really just one office for one person, or do we need even other kind of? I think railway system now also in the pandemic, we realized we are sitting in huge trains. People are very narrow together. And if you try to work in a train, you realize it's not a very good idea. Even if you fly with a plane to the United States or to Asia, working in the plane is not that comfortable as you really wish to do. And even if you are in the first class, you are limited at the end with the services, with the equipment that you have and how you use the equipment. Even today in the planes, you have an internet access, so you are at the end connected, but the way is not in that way how you could do that in a comfortable office. And so is the question at the end, how we manage at the end people, how we get them, that they are used in their environment, and also, how they can move safely wherever they want and where they need this kind of information. And so, for example, one job for me, of course, is driving with the kids to their sport facilities, going at the end to football matches with them, bring them to football matches, bring them safely to school, and also how we manage that crowd of people today. I think it's horrible. We get now also due to Corona the message that they use more buses because there are too many school kids at the end in one bus. And today it is normal that the school kids don't have even a seat in a bus. So they're all standing in the bus. And so there is also not a question of comfort. And here even, I don't know, maybe you know it better, but here in our area, it's half an hour driving from home to school. In the average, the children have to go at the end nearly 20 minutes to find the next bus stop, etc., and all that stuff. So it takes them 1 hour also to get to school for the school kids. That is really not that mode of transportation where we are dreaming. I think we are used to do that in the last years, but we start thinking if we really want this kind of transportation and if we accept that. The same is at the end with goods. So all the lorries, tons of goods are transported with lorries on the road. At the moment, all the autobahns in Germany are full of lorries, and you have really, due to traffic jam, no chance even to use a powerful vehicle on the motorway, because you are always also in traffic jam and you don't find at the end the way through the traffic. So the question is how safely you could at the end reach your target, and safely means also right in time. And so we are in a big battle with two words. One thing is availability, and the other point is really real time, right in time for the technical system. We didn't develop at the end any system in automotive industry which fulfill these two kind of requirements. I think most of the systems had some features at the end for real time, etc., but most of the systems didn't perform as required. And so you see ISO 262 exempted at the end nominal performance from the standard, but now we need it. And how do we manage, how we bring that at the end in the systems that we have at the end the nominal performance? How do we deal with that we get at the end the availability of the system, and of course also the availability of the mode of transportation? So these two terms changing at the end the game completely. And that is one point which lead at the end for us. It strongly need to change at the end the design also of the control systems.
You touched already ISO 26262. So for my audience, let me ask you a very fundamental question. What does safe transportation mean? And could safety and security be decoupled? Or do we need security in order to implement safety?
I strongly believe that we must be able to control the risk, because the users of the mode of transportation cannot control the risk. So the people, the occupancy, so the people are inside which are using, they cannot control the risk. They cannot work with networks. They cannot just work at the end with the electronics and prevent that a hacker really change the mode, or that something really change the behavior of a system, etc. I think that is a job of us engineers, and to bring at the end really the mode of transportation usable, and also prevent at the end that due to malfunctions, but also due to active sabotage and hackers, such a situation can change. And you see at the end, we just had in Germany again really catastrophic event where a car drove to the city of Trier, and he killed at the end, I think, 4 people. Even a 9-month-old baby was killed at the end. And such things we don't want to accept. And when you see at the end the horrible scenario that hackers have the possibility to manipulate vehicles, and that they could at the end steer or drive a vehicle into crowds of people, I think the society wouldn't accept that. And that at the end requires that we can prove that we are able at the end to show that we can control all that risk. And the risk is really a question coming from outside, from people, hacker, or however you want to call them, or it is an accident by people who handled that one, or it was a mistake by the people who developed that, or just a pure systematic fault in the organization who developed the mode of transportation and its automation system. And that is the responsibility of us all, and we must recognize that we are responsible at the end when we want to bring such a system. And we're coming at the end in a situation that the tendency becomes more and more that we share the risk, because it is at the end too much risk behind it. So I think when you do at the end all the analysis for security, when we make the different scenario, how it can come to accidents in safety, etc., we must combine our knowledge and bring at the end good solutions at the end, which still make the system performant and also available. Because that was the big battle that we have at the end between safety and security. You install the firewall, you install hashes, and safety make shutdown sequences. And when security is finished and when safety is finished, you have at the end no user function anymore. And that cannot be the solution for our future. So we have to question how we manage at the end, and how we are able to build systems which can manage all the risks which are necessary to be controlled. And here we need really, in my opinion, complete new way of thinking about systems.
Fascinating. So we have 16 years of history when it comes to ISO 26262 now. Now, in the 16 years, especially in the past decade, the automotive industry has gone through massive changes. It's still going through massive changes. One we talked a great deal about is electrification of vehicle. We will have autonomous vehicle, and we will have connected vehicle. All these technologies will change the landscape forever. So do you think ISO 26262, the functional safety standard, is the right answer for all these? What do we need in order to adapt to the upcoming disruptions in the industry?
I think one of the biggest life cycle standard was ISO 12207, which was the software safety, software life cycle approach, which gave us already a lot of activities which are necessary to make a high quality software. And we recognize that we need. And so we start with IC 61508, which is a life cycle approach, ISO 262, which is a life cycle approach. But the scope of ISO 262 at the end is strongly limited. So at the end, ISO 262 addressed only electrical control. And electrical control was based on the scope, so we could apply it just for one control unit. Even it was mentioned that ISO 262 is also addressing an array of systems, but they never explain what is an array of systems. So, but you cannot just say, yes, there are multiple systems. And so we have today really a challenge with system approaches. So we have one box in the other box, a box around, etc. But that is not a box. A system, in comparison to a component, you're questioning the environment, the context, and usability and functionality at the end that you provide at the end with all that stuff. And here, the interfaces are not fixed like a component. So a component is fixed to its specification, and you can define at the end where is the end and where is the beginning of a component. And so you can give that component also a reliability flag and can say for what function it is sufficient reliable. But with a system, you can just confirm at the end that certain criteria and that it works at the end in a special context or in a special environment with a certain reliability, but you never can say that the system as a standalone device is at the end reliable or safe at all. And so I think we must come back that we increase at the end the whole life cycle, for example, with the operation domain. I think maybe one of the biggest discussion now in the new legislation is, for example, the operational design domain. So when you deal with automation, you're discussing at the end, where is the vehicle driving, what is the road condition, what are the weather conditions, etc., and how they influence at the end the systems in the vehicle, and the most important thing, how they influence at the end the behavior of a vehicle. And that is one of the biggest challenges that we have today with automation. So to see at the end how we get a safe perception, how do a vehicle which is now doing all the tasks which humans are doing, could manage at the end all the situation, all the conditions about road, about sun appearing, animals, children, and whatever could appear suddenly in front of a vehicle. And these questions are enormous challenges that we have to develop such a perception system, but perceive at the end all the necessary things. And here also, whenever, for example, in terms of sabotage, you can at the end generate at the end phantom events, and you can simulate at the end environmental impacts which are not there, and the vehicle try to dissipate the road, and then you have the accident. And when you make that in critical situation, at the end you come up that you can really manage here very awful disasters when you really want to use that. And so the automation becomes at the end a real challenge, and the society, the people around recognize that that is possible, and they expect at the end from the engineers answers. How can we make such systems safe, and how we can assure at the end that hackers don't hack the system in a way that they can use such a fast-moving vehicle as a weapon against the society? We must give the answers. And here we must, of course, give the answers in terms of security, of safety, and also, of course, of usability, that we still can explain that there is a residual usability, so a benefit left of that vehicle, so that we can transport people or goods from point A to point B.
Leo, fascinating. I remember 2 years ago when we were having dinner together, you pointed me out to Fast and Furious 8, the way they make 1,000 zombie car rain. And like you mentioned, so that they cannot use a vehicle as a weapon. So, I mean, this is Hollywood, but I often tell my audience that this is a reality today. It is possible today. So this definitely, we got to take things seriously. And I totally resonate with your answer there. Now, I'm gonna go a little bit basic, because you mentioned system components. You know, I have a lot of audience time to time. They ask me these basic questions like, how do you, in terms of security, define an item boundary or a system boundary? And is it going to be the same for safety?
It's a good view, but at the end, when you compare safety and security, the high-level view is at the end, in functional safety, specific in functional safety, the risk is inside. And in security, the risk is coming from outside. And so at the end, when you see all the discussion that you have today in systems, when, for example, you're using in German, same word for security and safety, we call it Sicherheit. And when you ever read reports about Sicherheit in German language, they mix it completely up. And also in the society, you're talking about social security, but you mean safety to the people. And so the words are not really unique as we try as engineer at the moment to separate those stories. The question is always, can we do it just on one layer? And so, for example, there's one chapter in my new English book that we need really layer of protection, or how you call it in the other industry, layer of defense. So how you implement at the end different layer, because at the end you cannot just build one fence around the system and say, here is the border limit, and from inside the system should not go over that limit, and from outside nobody should go inside that system, and that you just build one fence. That makes the system too much heterogeneous today, because at the end you have different layers necessary to defend for certain things. Otherwise you don't get the usability to that target that you need. And here, for example, especially when you compare a system whereas the function at the end gives the capability that the system really provides a certain capability that the function fulfills the given requirements. And we have to build systems in such a way that they are capable to manage at the end the required function, but that they have both ends from inside to outside and outside to inside, but with a lot of penetration channels. And these penetration channels at the end, we have to protect. And just putting at the end here gateways or other means of interfaces to the system is not sufficient, because when you have at the end a secure entrance into a system, it does not mean that it is a safe entrance. We are working here with different mechanisms, and so we need to talk quite a lot of things that we find at the end mechanism which solve both problems, so that only those things go in which should go in, and that only the effects from outside which should go outside really go outside of the system. And that is not possible just with a single mechanism. And so we need clever solution how we combine at the end this different combination. That reminds us when we met each other first time. At that time, I tried to develop a basic software for an ESP system. I tried to find out how we can use the different resources on the system. I had in mind that we need something like a resource manager, which at the end manage all the resources of a system in a way so that it can also prevent at the end using resources which have at the end any constraints to its health, we say today. So you need at the end somehow predictive measures so that you see at the end that the system has also the capability to make a certain intervention. That means, for example, in the ESP, what happened when I start the ESP pump and open the valve? Could I really perform a proper ESP intervention to the vehicle? Are the system all available in such a structure? Or does the pump fail when I open the valve, and then the system really destabilize and you have a serious accident due to a malfunction of the system? So that is a combination of failure which are inside mechanical issues, which are inside the hydraulic flow, which are inside the electric information which going around. And even if somebody manipulates all that data, you can create serious accidents. And so we start to work out how we can manage that topic time. So you're starting to work on a round robin scheduler, and you find out how we can combine round robin at the end with different periodic tasks, with different sudden events, and how we can switch resources from one point to the other point, etc., and how we could work with such a scheduler, which at the end not affecting just the hardware resources of the microcontroller, but which manage at the end the entire resources of the entire system. And that cost us at the end a lot of thinking. But I think that is one example where we have to rethink all our system, because the easy scheduler which we think, for example, from AutoSAR, etc., it is not sufficient. And also when we're talking about today about adaptive AutoSAR, etc., when we increase the system by networks that we add at the end microprocessor to microcontroller, combine microprocessor and microcontroller, we still have to manage the resources of the controller or processor by itself, but we have also to manage all the system resources in a way and control the system resources, how we could manage them. And that is, in my opinion, quite a huge question where at the moment, you see, for example, Volkswagen. Volkswagen says they want to set up their own software company. They announce they want to make their own operation system. But software operation system, like an OSEC, etc., it's just a device which manage some resources in a microcontroller, but it cannot manage at the end the resources at the end and control the availability of interrupts for an entire function on vehicle level, etc. And so you need at the end really a mechanism which affecting at the end functionality on a much wider level as it is just in such a microcontroller or even in a microprocessor. By the way, we still don't have any microprocessor which is at the end certified according to ISO 26262. And as far I know, we still have at the end also no microprocessor which have any safety certificate at the end in generic usage. We just have it somehow in the context of an application. But a generic device which is at the end says, I'm using a microprocessor as a standalone processing unit and have developed that according to a safety standard or safety integrity standard, is, as far I know, still not available today.
Fascinating. Yeah, I remember the time we talked about this round robin thing, the scheduling problem when we first met. I remember. Yeah. So I'm switching gear a little bit because we also want to talk a little bit about two things that's coming up on top of ISO 26262, which is SOTIF and cybersecurity lifecycle. So do you think that we need them? And if we need them on top of ISO 26262, why do we need them? And how can we incorporate them in the current ecosystem?
I made the proposal that we make part 13 of ISO 262, which deal at the end with SOTIF and explain how we can integrate at the end nominal performance in the given life cycle from ISO 26262. But then people realize, no, part number 13 is not a good number. And so they tried to write their own standard. And
just for our audience, can we first ask you the question, what is SOTIF for some of our audience?
It's difficult for me. At the moment, it was just the nominal performance of environmental sensors, which provide at the end the gap of this perception systems. And the current standard, which had been published, just addressing this topic. The new development of SOTIF at the moment is a huge discussion. So maybe a few weeks ago, there was Safetronic, where we met also quite often, and we had also passionate discussion. Yeah, what are the topics? Is SOTIF more safety functions on vehicle level? And do they addressing more the safety functions, especially the nominal performance on vehicle level? do we addressing with SOTIF also the nominal performance of actuators and of general control algorithm? How do we deal with timing? I think we have the fault tolerance time interval, and so maybe we need an external event, and how fast we react at the end on an external event to extend that by ISO 262 to address that. But the big gap I see at the moment in all that discussion, we had at the end ISO 262 was neutral and gave just also here a high-level answer, but never addressing closed-loop control systems. And we never had in mind that it not should address closed-loop system, but at the end, any closed-loop system normally have an interface to the real world. And that real-world interface, so the road at the end for a brake system or for a steering system, the weather condition which are influenced, you cannot make a contract with the weather. So you have to consider at the end nearly all kind of information and disturbances in your feedback of the closed-loop system. And that shows at the end why are the limitations of such a SOTIF standard. So the question is really, can you deal with such limited that you say I just addressing the nominal performance of a control system, of an electronic control system, or do you have to consider at the end the nominal performance of an entire system, including at the end the environment where it is operating and also the other technology which is addressing? And so you're coming up always that at that point, BOS standards doesn't cover sufficiently really the interfaces of open world or the interfaces to the real world. And we must find at the end really solutions how we deal with the real world and the interfaces with the real world. And then we are back to security. Because at the end, when we have at the end the standard written which prevent at the end that inside out no risk comes up, we need also somehow standards which cover the outside in come up. But unfortunately, whenever you have a real world standard, and it's not just the hacker who can influence in a negative way your system, it's the entire environment. So bad weather, corrosion, EMC, and all that stuff can also influence the system from outside. And if it is really a hacker, or if he is using a means of mechanism, for example, by EMC to influence the system, Hassan, I doubt that we can do that with standards. And whenever we deal that here with standards, we always coming up at the end that we have just one solution provided with the standard, but we have not a solution for an entire system provided. And here we have to see at the end into other industries. Other industries don't separate at the end safety and security. And they at the end have always standard how to manage the risk. So, for example, machinery industry, they have the regulations with the machinery regulations. They have at the end, of course, risk standard, for example, ISO 12100, which deals at the end the risk of machinery. So the reason why there is a risk is that you operate at the end a machine. And the risk that we have today with our modes of transportation, which we call our road vehicle, is at the end the fact that we have a moving object. And unless that moving object, you have a certain risk that people in the environment of the vehicle could be somehow hurt or involved in an accident with that vehicle. And the fact that the vehicle is full of kinetic energy means at the end a certain risk, and we must learn at the end how to manage and how to deal with that risk. And for that we need at the end, of course, in machinery industry you call that at the end organizational measures. These are all our road traffic regulations, how to deal at the end, for example, with automated vehicle, what are they allowed to do, where they are allowed to drive. Because at the end, for example, in a normal urban road, especially on a German-style road, you don't have a chance. Normally, for example, when you make your driving license, you are taught to manage at the end all serious situation. And when you are in a situation which you cannot manage, you have to slow down with driving in order to prevent the occurring damages. So that is your task during driving. And whenever you say we have a limit in the perception of our system, so we cannot at the end perceive all the critical situation in the mean, we have to slow down. But that means at the end, all the automatic vehicles today have to slow down to a speed which we don't want. And so they're going at a very low speed to our urban cities because they are limited in the perception of the environment. And that is the question, how we deal, how we get that we train the systems much better. The question is really how we deal with artificial intelligence. Do we need at the end machine learning, or do we need at the end intelligent algorithms which are learning the environment, which are based on empirical algorithm and not based on machine learning algorithm? So we need at the end a kind of artificial intelligence which are similar like the humans, which learn continuously to improve at the end their performance, and that they improve continuously their ability, etc., and all that stuff. And we must find mechanism how to release that during driving so that the vehicle at the end can use as much as possible. But at the end, a small child with very low experience, which is not that much trained as we see it today, you must protect it, particularly in the road traffic environment. And whenever you get grown ups, you're starting to move faster and you are able to manage at the end all the risks that you know from road traffic. And this is at the end the same which we have to do with our system. But all the history, with all the experience that we have in our genes, so that we have already from the history, whenever suddenly came up something, when something with a strong noise come to up and we go somehow in a good situation and try to find at the end protection somewhere, we must build all in a car. And then, of course, all the mechanisms which are aware, the regulations, etc., how we share the road space that we have, or how we react at the end when people make mistakes, etc., and all that stuff. It's all big question mark, but otherwise, my opinion, automated vehicle will not accept it if we cannot manage all that stuff. And it seems to be also, I think Elon Musk is a little bit not happy about the situation with the regulation, but at the moment the rule makers tell him very serious, since the system cannot manage all that stuff, they don't get the homologation. They get at the end preliminary homologation for small fleets to make experience by the industry, etc. But all the occurring damages, you have to pay for that. That is product liability. And I think the governments worldwide don't accept them. They have different way how they're making rules. So the Americans say you can do whatever you want. Unless an accident happened, you have to pay for it. And when you have really gross negligence, then also you go to prison. In Germany, the rule makers try to prevent for such a situation and give you very hard rules and give you a very narrow corridor in what you are allowed to move. And China at the moment is looking somehow to find, for example, a way in between that they allow at the end their companies, but also here you see at the end, whenever accident happened, you need somebody who is responsible and who can compensate and can avoid at the end and take measures to avoid such accidents. And so we have to find solutions that we can forecast, that we can predict accidents, and that we can make sure that our systems always able to perform the necessary protection and safety mechanism, independently if they are for safety or for security or something in between.
Amazing. Now that you mentioned the legal aspect a little bit, legislation, so I also see there are certain challenges. For example, harmonization. Now, we have several bodies. We have ISO, which is driven by the European motor industry primarily. We have SAE, which is mainly driven by the US mobility industry. We have IEC from robotics and machineries. We have ETSI from telecommunication. So how would this legislation be harmonized? Because the reason I'm asking is A vehicle is using a telematic control unit, which is adhering to the telecommunication standard, and so on. So we're actually mixing all of these. It's a blend of many technologies from all over the places. So how would that be harmonized?
The first step is really what you mentioned are all just standards, and these are not the legislation. The legislation in America is FMVSS, for example, the Federal Motor Vehicle Safety Systems. And here in Europe, we are applying more from the UN, the ECE, which are more or less the European focus legislation, which we consider for the homologation of the vehicle. They have to provide in the first set at the end harmonized structure. And since the legal systems in US and, for example, in Europe are widely different, it's very difficult also to harmonize the standards, which give you a guideline how to fulfill at the end those legal requirements. And here we must find at the end solution. There is a huge approach which try to harmonize, especially the worldwide homologation standards. So maybe it was also, I think it was 1956, I'm not aware, maybe I have to read my book again, when they define at the end the Vienna Convention. And that was a huge agreement which has been written in French, in Russian, in Chinese language, in English language, etc. So I think it was 6 languages where they published at the end the principles how to use public roads. And in that Vienna Convention, there were really huge basics regulations, but it said at the end one point that you as a driver have to control the vehicle, and even when you have your donkey on the road, the person who guides the donkey is responsible when the donkey makes any serious issues somewhere in the road traffic. And so they had something responsible. And now we change in 2016 the Vienna Convention and said also a system could at the end control such a machine called motor vehicle. And now we are in the obligation to work out solutions. And the standards say at the end just an agreement of experts how we can solve that issue. And here we have to find really approaches. So, for example, the Americans have a different approach. They think different. And so in their SAE standards, they say, yes, we would do it in this and this and this way. And so they define SAE standards. So, for example, most of the famous one in automated driving is the standard which define the level of automation. But the level of automation, we realize it is not such a sustainable empirical approach that you come from level 1 with some improvement to level 2, to level 3, to level 4. And since you have in level 5 fully autonomous driving, no, it's not true. Whenever you take the driver out of the loop and you bring the system into the loop, you have an automation system and it's not anymore an assistance system. And that requires complete other engineering disciplines. One of the biggest chapter, my chapter 3 in the English book, is about cybernetics. And cybernetics is at the end the mother of all communication technology, but also the control theory is based on cybernetics approaches. So 100 years ago, for example, Norbert Wiener was one of the people who define at the end the cybernetics. He tried to improve at the end rocket systems, and he find algorithm, cyclic algorithm, how to improve that and how to bring it forward. And he starts to discuss, for example, with people like Heinz von Förster. Heinz von Förster was a native Austrian, and Heinz von Förster starts with bionic. And bionic at the end was the idea to develop at the end a computer system which operate like a human body. And here we are really at the moment in something what we learn in automation, that we need also systems which work and which could at the end fulfill the capability of humans. So for example, when you have a reflex, how do you teach at the end the system to perform a reflex? How do you do that on system level? On controller level, I think we discuss it. You have an interrupt. So here at the end, you push an interrupt and then you change addressing. You change at the end the tables that you are using. You at the end put your context switches somewhere in a different context. You put your pointer in a different area. And then you have a very good chance at the end to manage that. But in an open world, in a real world scenario where you need such a reflex and how to manage with such a reflex, you need to system and you need to be sure that you perceive everything which is necessary to manage such a reflex in a system. And that is a very ambitious thing, since a reflex is a very fast reaction, and doing wrong thing, for example, with a steering system in the wrong situation, means at the end immediately an accident.
Leo, I'm really fascinated. For the interest of time, I think we'll have to do a follow-up on this one. I mean, the discussion definitely deserves a part 2, which we should schedule once more. However, for the interest of time, I have one last question to you today. So I'm getting back to the birth certificate of ISO 26262. It really gave me goosebumps. And my question to you, you were there from day one of ISO 26262, and this standard had so much influence in the entire industry. It's been used by so many people, so many experts. How do you feel about that?
It's a good question. At the end, you feel like an old man, and you're talking about, oh, it's long ago and it's history. So we have now end of 2020. It was in 2004. And so it's 16 years ago. It's not that much time. But when you see what the industry changed, what the situation changed, and we didn't perceive it really. And so we recognized due to the pandemic situation that really we must change something, and that also a lot of things change. And I think that is now the question, are we prepared to work on that change? And that is the question. I don't feel not too old to work on that change. And so I think, and I invite everybody to work on that change which is coming up with the digital millennium.
Fascinating. I love that. So we will definitely get back to you on the other issues that we talked about. I have noted down so many questions today because you're touching on so many stimulating points. Due to interest of time, we will wrap up this episode here. But if you would agree, I'm totally up for another part 2.
Yes, maybe after Christmas.
After Christmas. So Leo, thank you so much for being with us. It was lovely having you.
And also very pleasant year's end for all the audience, and enjoy at the end the time, and please healthy for all the people.
Yes, thank you so much, Leo. You also be healthy, and I also wish all of our audience that stay healthy, stay safe, and stay with us in our Autonomous Vehicle Safety and Security podcast. Thank you so much for watching. If you have questions, comments, feel free to write in the comment section below. I will answer them, our team will answer them, or in this case, you will have the legend of functional safety who was there from the birth of ISO 26262 till now to answer your questions as well. Thank you so much for being with us.